Good morning, students. Today, exercise 3.5, second problem, we are going to see. Examine for the rational roots of 2x cube minus x squared minus 1 is equal to 0. So, examine for the rational roots. So, whether this polynomial equation having rational root or not, we have to check. So, to check that, first we are going to see what is rational root theorem. So, let an x power n plus an minus 1 x power n minus 1 plus etc. a1x plus a0 with an not equal to 0 and a0 not equal to 0 be a polynomial with the integer coefficient. Here we have taken the polynomial of degree n. Here an is the coefficient of x power n and a0 is the constant. Both are non-zero. So if you consider this polynomial, if p by q with the condition p and q having no common factor other than 1, that is 1 is not a multiple of other, is a root of the polynomial. Which is the root of the polynomial? P by q. If p by q is a root of the polynomial having the condition p and q having no common factor other than 1. If it's so, then p is a factor of a0 and q is a factor of an. Okay, so using this we are going to do this problem and we are going to examine whether this equation having rational root or not. So for that, an is nothing but the coefficient of highest degree of the equation. So here the degree is 3. So an is equal to the coefficient. So here you will have 2 and a0 is the constant, that is minus 1. So according to the rational root theorem, if p by q is the 0 of this polynomial, okay, then as p and q having no common factor other than 1, your p must divide which one? a0. That is, here I have written p must divide minus 1. So using rational root theorem, what it says, p is a factor of a0. So here p is a factor of, what is a0 here? Minus 1. So therefore p must divide minus 1. And q is the factor of an. What is an? 2. So q must divide 2. So the possible values of p are, what are they? It is 1 and minus 1. And q must divide 2 means the possible values of q are 1, minus 1, 2, minus 2. So p and q, how they are? They don't have the common factor other than 1. So we'll stop 1, minus 1, 2, minus 2. We are not going for higher values. Okay, so using these values, we are going to write the possible fractions. What has to come? 1 by 1, that is 1. 1 by minus 1, minus 1. 1 by 2, that is 1 by 2. 1 by minus 2, that is minus 1 by 2. The same way, if you take minus 1 by 1 is minus 1. Minus 1 by minus 1 is 1. And minus 1 by 2 and minus 1 by minus 2 is plus 1 by 2. So the fraction, what are the fractions will come? Plus or minus 1 and plus or minus 1 by 2. So each fraction has to be substituted in this equation. If it is satisfied, that is the root, rational root of the equation. I'll take the first one, it is 1. So when x equal to 1, if I substitute in this, 2 minus 1 minus 1. So 2 minus 1 is 2 minus 2, that is 0. So when x equal to 1, the polynomial, this equation is satisfied. So therefore x equal to 1 is the root. Okay, so instead of substituting all the values, what I'm going to do, using synthetic division, I'm going to find the remaining factor. So the cubic polynomial. So what are the coefficients? It has 2 minus 1. Here x is not, x coefficient, x term is not there. So therefore 0 minus 1. I have substituted 2 minus 1, 0 minus 1. We have found 1 is the root. So here I have written 1. So we use the procedure of the synthetic division. We have found this. So this is the remaining factor. So we have, what is the remaining factor? 2x squared plus x plus 1. So when it is equal to 0, using this formula, we have found the roots. X is equal to minus 1 plus or minus root 7I by 4. So this is nothing but imaginary roots. So how many roots it has? 1 was the one root, another 2 roots are imaginary roots. Here what is asked? Examine the rational roots. So you will have only one rational roots. So instead of doing this, what you can do? You take each root and substitute in this polynomial. If it is equal to 0 means that is the root. Okay, it is not equal to 0 means it is not a rational root. So instead of substituting each value, I have done this problem like this. Okay, but then I will conclude x equal to 1 is the rational root. And coming to the second problem, x power 8 minus 3x plus 1 is equal to 0. So it has how many roots? 8 roots it has. Okay, so here first you just consider an, that is 1. So the coefficient of x power 8 is 1 and the constant term is 1. So p by q is the 0 of the polynomial and with the condition p and q having no common factor other than 1. So p must divide a0, or p is the factor of a0. So p must divide 1. Here a0 is 1 and q must divide an. So that is 1. So here p must divide 1 and q must divide 1. So the possible values of p are 1 and minus 1. They are in the same way q, the possible values of q are 1 and minus 1. So what are the fractions will come? 1 by 1, 1 by minus 1, or minus 1 by 1, minus 1 by minus 1. So you will get plus or minus 1. Take plus 1. And p of x up, the polynomial alone I have considered. Take plus 1. If I substitute, here 1 minus 3 plus 1. So it is 1 plus 1 is 2. 2 minus 3, that is minus 1. So it is not equal to 0 because the polynomial here it is equal to 0. So here it is not equal to 0 means 1 is not the root of this polynomial equation. And consider minus 1. So if you substitute minus 1, the whole power 8 is plus 1. And here minus 1, if you substitute, minus 3 into minus 1 is plus 3, plus 1. So again it is a 4 plus 3 plus 1, 4, 4 plus 1 is 5. So which is not equal to 0. So therefore minus 1 is also the is not the root of this polynomial equation. So this equation has no rational roots. We are not going to find the 8 roots. So we have examined it as whether the equation has a rational root or not. So we have found the possible fractions and those values has to be substituted in this equation. The equation is not satisfied. So the equation has no rational roots. Okay, so see now, next one, we are going to see the next exercise 3.6. The first problem, discuss the maximum possible number of positive and negative roots of the polynomial equation. So we are not going to solve the equation. We are going to find what are the maximum possible number of positive and negative roots of the polynomial equation. So for that, the procedure, you take the polynomial, consider as p of x, and you have to count the sign changes, number of sign changes. You see that this term is positive, the next term is negative. So it changes the sign from positive to negative. So it is one change. And negative to positive, that is the second change. Next, plus to minus, so that is the sign changes 3 times. And negative to positive, so 4 sign changes happened. So remaining plus, plus, and here also everything is plus. So therefore the number of sign changes in p of x is 4. So therefore the maximum number of positive real roots is 4. Maximum number. So it may be 0 real root or 1 real root or 2 real roots or 3 real roots or 4 real roots. But we don't know what it is. But the maximum number of positive real roots is 4. We are finding according to the number of sign changes. And next we are going for the negative roots. So for that you have to consider p of minus x. So what you have to do, wherever you are having x, you have to substitute minus x. So 9 into minus x the whole power 9. So therefore it is minus 9x power 9. Here minus x the whole power 8 is x squared. So minus 4x squared. Here minus x the whole power 7 is minus 4x power 7. Here minus x the whole power 6, what has to come? It is plus x power 6 only. So the term you have to write as it is. Here the power of x is odd, means you have to write minus. So minus 2x power 5. Here the power is odd, so therefore minus x cube. And here the power is even, power of x is even, so therefore the same thing has to come. Here the power is odd, so it is minus 7x and the constant plus 2. So p of minus x we have found. You see that where is the sign change? Here all the terms you are having minus up to this. Next term is positive. So the number of sign changes positive to negative is 1. So here plus and minus. So therefore the changes, number of sign changes is 2. Next negative to positive. So 3. So the number of sign changes in p of minus x is 3. So the maximum number of negative roots is 3. So here maximum number of 4 positive real roots. Here 3 maximum number of negative real roots is 3. So the maximum number of real roots it is 7. 4 plus 3 is 7. So here this equation has how many roots? 9 roots. So therefore the remaining 2 roots, they may be, what is it? Imaginary roots. So therefore the equation has at least 2 imaginary roots. Okay. So in this way we can find the maximum number of positive roots and the negative real roots. Coming to the second problem, discuss the maximum possible number of positive and negative zeros of the polynomial. 2 polynomials given. Also draw rough sketches of the graphs. You consider the first polynomial's name as f of x. See the sign changes. Plus 2 minus, minus 2 plus. So the number of sign changes is 2. So the maximum number of positive real roots is 2. Take f of minus x. So minus x the whole square is x squared. If you substitute minus x here, it is minus into minus plus 5x plus 6. So see, all the terms are positive. There is no sign changes happened here. So the number of sign changes is 0. So therefore maximum number of negative real roots is 0. So this polynomial having only 2 positive real roots. That means 2 positive real roots means maximum number of positive real roots is 2. That may be, it may have 0 real roots or 1 real roots or 2 real roots. And consider the next one. Next polynomial x squared minus 5x plus 16. You see the number of sign changes in that, it is 2. So the maximum number of positive real root is 2. And p of minus x, if you substitute minus x the whole squared is plus x squared. And here if you substitute x as minus x means it is plus 5x plus 16. So the number of sign changes is 0. So the maximum number of negative real roots is 0. So therefore this equation having maximum number of positive real roots is 2. And no negative real roots. Here also the same thing. So here when the question board is asked, also draw the rough sketches of the graph. So I'll take the first one, f of x. Here I have taken some points. See, minus 3 to plus 4. Okay. So see now minus 3, if I substitute here, minus 3 the whole squared is 9. 9 plus 6 is 15. Okay, so here x has minus 3. So minus 5 into minus 3 is plus 15. So 15 plus 15 is 30. So like that, here if I take 0 if I substitute, I will get 6. And if I consider x as 1 means 1 plus 6 is 7. 7 minus 5 is 2. And if I say take x equal to 2 means it is 2 squared is 4. 4 plus 6 is 10. Here x as 2 means it is minus 10. So 10 minus 10 is 0. And if I take 3, 3 squared is 9. 9 plus 6 is 15. Here if you substitute x as 3 means minus 5 into 3 minus 15. So plus 15 minus 15 getting cancelled. So here also 3. So you see now first minus 3 comma 30 I have marked here, and minus 2 comma 20. and minus 1, 12 I have marked, 0, 6 and 1, 2, 2, 0, 3, 0 and 4, 2. So it's a parabola. Okay, you see that this curve touches the x-axis at the point 2 and 3. So therefore it has how many positive real roots? It is 2 and 3. There are 2 positive real roots. So no negative roots here. Okay, so coming to the second one, f of x is equal to x squared minus 5x plus 16. The same way I have taken the points. So I have marked it minus 3, minus 2, 30 here, minus 1, 22 and 0, 16, 1, 12 and 2, 2. You see that the curve does not touches the x-axis. So therefore it has no real roots. But what we have written here, the maximum number of positive real roots is 2. That means it may have 0 real root or 1 real root or 2 real roots. Here on seeing the graph, this equation has no real roots. Okay, so see this. Next one, we are moving to the problem number 4. Determine the number of positive and negative roots of the equation. So consider this polynomial p of x. So the sign changes is 1. Here also negative, here also negative. So the positive real root is 1. And if you substitute x as minus x, p of minus x is equal to minus x power 9. Here if you substitute minus x, the whole power 8 is positive. So minus 5x power 8. If you substitute x as minus x, so minus x the whole power 7 is minus, so minus into minus is plus, plus 14 x power 7. So here only negative to positive, one sign change. So the number of negative real root is 1. So it has one positive real root and one negative real root, the maximum number. And coming to the third problem, show that the equation has at least 6 imaginary solution. So first we are going to find the real roots, and then after that we can conclude the imaginary solution from the real roots. So p of x you have considered, and how many number of sign changes? Here happened 1 and 1 more, minus to plus. After that everything is plus. So the maximum number of positive real root is 2. Okay, next we have to go for p of minus x. So it is minus x power 9. Here minus into minus, plus 5x power 5. Here plus 4x power 4. Here plus 2x squared plus 1. So negative to positive, one sign changes happened. So therefore the negative real root is 1. So positive real root is 2 and maximum number of negative real root is 1. So therefore the maximum number of real roots, whether it is positive or negative, the total number of real root is 2 plus 1, that is 3. See this equation, it is whose degree is 9. So it has, the polynomial equation has 9 roots. The out of 9 roots, 3 roots are real roots. So therefore the remaining roots, they may be imaginary roots. So therefore you see that the given polynomial equation has 9 roots. So there are 3 real roots we have said. So therefore hence there are at least 6 imaginary roots. So we have proved the result. And coming to the problem number 5, find the exact number of real zeros and imaginary of the following. So the same way, p of x you just find out. P of x is written. So the number of sign changes, so everything is positive, no sign changes happen, so it is 0. So the maximum number of positive real zeros is 0. P of minus x, if you consider all the powers of x are, what is that, odd number, so everything will become minus. You see the sign. So here the number of sign changes also 0. So the maximum number of negative real zeros are 0. So the given polynomial has no real zeros. So hence there are 9, at least 9 imaginary zeros you will have. Thank you students.